In this presentations, we are going to discuss about the runtime environment and code generation with the subtopic optimal code generation for expressions. So where we can choose the registers optimally when the basic block consists of a single expressions evaluations, or if we accept that it is sufficient to generate a code for a block one expressions at a time. So the following algorithms we introduced a number of schemes for the nodes of an expression tree, where the numbering scheme is used to generate an optimal code for a given expressions. That's an Ershow numbers. So we begin by assigning to each nodes of an expression tree a number that tells how many registers are needed to evaluate that nodes without storing any temporaries. So these numbers are sometimes called a Ershow number after the Ershow who used a similar schemes for a machines with a single arithmetic registers. For our mission model, the rules are label all leaves. How to find the registers needed for a expressions tree. So initially first label all leaves. The label of an interior nodes with one child is the label of its child. The label of the interior node with the two child is, it has two options. The first one, the largest of the labels of its children if those labels are different. If the labels are same means 1 plus the labels of its children. So we can choose the registers optimally when basic blocks consist of a single expression evaluation. So example, we have the expression a minus b plus e star c plus d. So it's the corresponding three address code as T1 is equal to a minus b, T2 is equal to c plus d, T3 is equal to e star T2, and T4 is equal to T1 plus T3. Here the higher precedence for the bracket. So the syntax tree is drawn for that given T address code, where the leaf nodes, all the nodes are labeled. Okay, so for the leaf nodes has the label is 1. So A is a leaf node, B is a leaf node, E, C, D all are 1. So then next move to the interior node. So for example, the node for the T3 is equal to E star T2. So its children has a label 1 and 2. So here the child labels is not same, there is a difference. So the label of the T3 is the highest label, there's a maximum value label is the interior node, there's a parent node, so it's also as a 2. Generating code from labeled expression tree. It can be proved that in our mission model, where all operands must be in the registers and the registers can be used by both an operands and the results of an operations, the labels of the nodes is the fewest registers with which the expressions can be evaluated using no stores of temporary results. Since in this model we are focused to load each operand and we are forced to compute the results corresponding to each interior node, the only thing that can make the generate code interior to the optimal code if there is a necessary stores of the temporaries. So that is an arguments of the claims is embedded by the following algorithms. So this algorithms describes how to generate the target code, that's an assembly language for the given expressions by using the syntax tree and its label, because the label is described how many registers are used. So in this algorithm's main concept is it recursively generates the code for the left child, right child, then in the parent child. Thank you.